Hello YouTubers. This video is a small demo on how to use organization blocks that interrupt your program and execute some code that is inside of them once or periodically. For that kind of tasks, Siemens provides 8 OBs, starting OB10. So it will be OB10, 11, 12, 13, 14, 15, 16, and 17. What we will be talking about is the functions that you want to execute on regular time. For example, you want to start a test of some equipment once a month. Or you want to write data from data block to some remote server, and so on. There can be a lot examples of its usage. Open hardware configuration of your project, then open up properties of the CPU, and switch to the tab Time of Day Interrupts. Keep in mind that not all CPU supports all the time of day interrupt OBs. You need to check the user's manual of your CPU to find out which time of day interrupt OBs are supported. My S7 315-2DP CPU is kind old, and it supports only one time of day interrupt organization block, OB10. Other CPUs supports way more. Time of day interrupt OBs are processed on the regular intervals. First execution interval is once. It means that your interrupt will be executed only once, at the exact time that you have set. After that, no more interrupts will be executed. Every minute. This interrupt will be executed every minute from your set time. After minute has passed, the time of day interrupt will be executed. After another minute, another execution, another minute, another execution, and so on. Besides every minute interval there are other intervals, hourly, daily, monthly, end of each month, and every year. Time of day interrupt executions of these intervals will be executed same way, as I already explained, when talked about every minute execution. So if you select weekly, then your code will be executed once a week. If you select monthly, it will be executed once a month, and so on. You need to take into account that end of month execution has some limitations. Interrupt days can be only from day 1 to day 28. And I believe you have already understood why it is done that way. If not, then the cause is very simple. Not all the months have 29, 30, or 31 day. Let's say January has 31 day. February has only 28 days. And it has 29th every 4 years. April has 30 days. And so on. So, now we know the intervals and limitations. Let's talk about the conditions of time of day interrupt. To start a time of day interrupt you must set interval, starting day, and you need to activate it. If you will set the interval and start up day, but you will not activate it, then no execution will be performed. So you always must set interrupt and activate it, that's the law. There are 3 possible scenarios to perform these tasks. 1. Automatic start of the time of day interrupt. You can set it by the help of step 7, in the hardware configuration. It's the easiest method, but it requires the restart of the CPU, as any changes made in the hardware configuration requires to stop CPU upon download of the configuration. So each time you set, or change the interrupt, you need to stop the CPU, upload the configuration to the CPU, and start it over. Like I said, this method is easiest, but also it is most inflexible. Scenario number 2, you set time of day interrupt with step 7, but you activate it by calling special system function, SFC30. This method makes your system more flexible, as you can start or stop your time of day interrupt programmatically, but again, you will use step 7 in order to change the date. And you will be in need to stop the CPU, upload new configuration, and start it over. Scenario number 3, is when you set the time of day interrupt, by calling system function sfc28, and then you activate it by calling system function sfc30. This method is most flexible one, as you do not need to upload hardware configuration to the PLC. Everything is done programmatically. So, what have we learned? If your time of day interrupt is not activated, you can activate it by calling sfc30. If your interrupt is configured activate once, then OB is cancelled automatically after it runs one time, but it can be reused by calling sfc28 and sfc30. Activated periodically, when the interrupt occurs, CPU calculates the next start time based on the current time of day and period. What happens if you move time forward or backward, like daylight saving? In case you will move forward, then OB80 will be called. If you move time back, then execution of the time of day interrupt will be repeated. Copy and paste OB10 from library to your project and open it. Like OB1, that I have talked about in previous video, it has some predefined variables in the variable declaration table. It has same count of variables, but less usable. Let's walk through them. First one is event class and identifiers. Second one helps to identify the scan status. Third one is priority class. Fourth, OB number. Fifth and sixth, reserved for system. Seventh, period of execution. 8th and 9th, reserved for system. 10th, date on which OB was called. Let's write a simple application, that one tag is incremented every 1 minute, and date of OB10 call is updated. Create new data block. Open it, and create tags as follows. CNT up will hold the increment of calls of OB10. OB10 date and OB10 time will hold the values of date and time of the last call of the OB10. At first, we will use first method. OB10 is activated in the hardware configuration of the PLC. Start the hardware configuration of your project. Open properties of the CPU, and switch to time of day interrupts. Select execution as every minute, set the start time, but leave activate unchecked. Compile, save, and load to the PLC. Create new data block. Add integer type variable to count executions of the OB10. Also, we gonna need date and time of day variables to store the date and time in readable format. Open up OB10, and write mathematical sum function, that will increment our OB10 execution count. Call two system functions, that will convert date time variable into readable format. You can find more detailed demo on how to manage system date and time in my previous video. Link is in the description. Download everything to the PLC. Let's test our application. At 18:05 first increment should occur. As you can see, the time has been reached, but counter did not count any OB10 execution. Let's wait 1 more minute. Nothing again. It means that OB10 has not been called due to inactivity of our time of day interrupt. We need to get back to the hardware configuration, checkmark activate the time of day interrupt, and download to the PLC. Let's test again. It worked this time. Let's wait one more minute. Success again. As you can see, time of day interrupt executes only after it has been activated. Setting date and time is not enough. Let's try another method. We will set the date and time in the hardware configuration, but execution of the time update will be activated programmatically, by the help of the system function SFC30. Open hardware configuration, properties of the CPU, deactivate the time of day interrupt, and load it to the PLC. Insert SFC30 call into OB1, assign OB number 10, and download to the PLC. Let's test again. Minute passed, but nothing happened. Time of day interrupt is inactive. Let's try to activate it. As you can see, time of day interrupt was executed, because we have got one count up, and date and time were updated. Let's try third method. Add 3 more data types in the data block. One of them is date, another one is time of day, and third one, date and time. Last one will contain the date and time value, that will be combined from date and time of day. Get back to OB1, and add function FC3, it will combine our date and time of day variables. Also add system function SFC28, it will change the date and time of the time of day interrupt. Download everything to the PLC, and let's test it. Set new date and time interrupt set point. Activate new set point, and let's see what will happen. As you can see, our time of day interrupt was not executed, as system time did not reach our new set point. Let's wait a minute. This time, time of day interrupt was executed as system time has exceeded our set point. Let's change the set point one more time. Nothing happened again, as system time did not reach new set point. System time exceeded new set point and our counter has been incremented. As a bonus, let's implement time of day interruptibility to be deactivated programmatically. To deactivate time of day interrupt system function SFC29 is need to be used. Paste it into the OB1, set the number of OB, and download newly update to the PLC. Let's test it. Our time of day interrupt is currently active. Let's reset the counter. We have got one count up. Let's deactivate the time of day interrupt. As time of day interrupt is inactive, our counter did not count up. Let's activate it again. We have got one count up, because time of day interrupt is active again. Well, that was a demo on how to use time of day interrupt. Don't forget to like the video, and subscribe to the channel. Thank you for watching and happy coding.